Okay, 6.3 day 2, logarithmic functions. We're going to graph logarithmic functions today. Okay, so let's graph f of x equals log base 2 of x. I'm going to use a table for the first couple, and then we're going to try to see how we can do it without a table. Okay, so I need to pick an x value that's going to be convenient here. The base is 2, so I want 2 to the something to equal that. Okay, I'm gonna pick a number. I'm gonna put 4 in here. I'm gonna show you why in a second. Okay, so if I do log base 2 of 4, so I put this on the side. I'm saying 2 to the something equals 4. 2 to the what equals 4? 2. So I'm gonna graph 4, 2. 1, 2, 3, 4, 2, which is up here. Okay, now I'm gonna pick another number that's gonna be convenient with a base of 2. I'm gonna do 2. If I do the log base 2 of 2, I'm saying 2 to the something equals 2. So what's the exponent that gives me 2? 1. Let me graph that as I go. 2, 1. Okay, now how about I'm going to plug in 1, and we'll see why this is a useful point. Okay, if I do the log base 2 of 1, that's saying 2 to the something equals 1. 2 to the what equals 1? Always 0. Okay, now I want a couple fractions in here, which normally we don't, but today we do. I'm going to put 1/2. The reason I'm doing 1/2 is because if I do the log base 2 of 1/2, 2 to the 1 gives me 2, but the negative 1 gives me a fraction. I'm going to do 1/4. Okay, 2 squared is 4, but to get a fraction, it's going to be -2. Okay, I'm going to graph these 2 points. So 1/2 -1 is right here. 1/2 -1 is way down here. I'm going to guess it's about here. Now, if I do 1/4 -2, I'm going to go over 1/4, which is barely at all, and then I'm going to go down 2, which is like right here. Okay, I'm going to draw the shape of the graph so you can see what it's going to look like. Okay, it does not cross the y-axis. It goes up, and then it goes this way. Okay, just like exponential graphs didn't cross the x-axis, logarithmic graphs don't cross the y-axis, or at least their parent functions don't. Okay, this is the shape of a logarithmic graph. Now that we've seen the shape, we're going to try to graph it using fewer points. Okay, now I'm going to do log base 5 of x. Okay, since it's log base 5, I'm going to plug in 5. I'm going to try to do this with only 3 points. Because if I do the log base 5 of 5, that's saying 5 to the what gives me 5. It should be 1. So I'm going to graph 1, 2, 3, 4, 5, 1. Okay, the next point I'm going to use is 1. If I do the log base 5 of 1, I'm saying 5 to the something gives me 1, and that's always going to be 0. Okay, and since my base was 5, I'm going to put one fraction in here, and my fraction is going to be 1/5. And that's because if I do the log base 5 of 1/5, 5 to the 1 is 5, but to make it a fraction, it's going to be, no, 5 to the, yeah, -1. So 1/5, -1, I'm going to graph that point. 1/5 is very close. -1 is down here. Okay, which would not be enough information generally, but because I know the shape of the graph and I know it does not cross the y-axis, that's enough information for me to tell that it's going down over here, and it's going this way over here. Okay, let's sketch a graph of a general logarithmic function so we can find a good pattern for graphing it. Okay, if I do the log base b of x, the asymptote is going to be the y-axis, which is a vertical line, which means it's going to be at x equals 0, because that gives me a vertical line right here. Boom, 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 boom. Okay, I'll draw it in, but when it's right on top of the axis, we don't always draw it because you can't see it anyways. Okay, the x-intercept. For this one, the x-intercept was 1, 0. For this one, the x-intercept is 1, 0. Okay, so generally the x-intercept of a logarithmic function is 1, 0. The reason it is because if I do the log base b of 1, b to the 0 gives me 1 every time. So 1, 0 is always on my graph. Okay, I want to get 2 other good points. Okay, when I did the log base 5, I picked 5. Because when I do the log base 5 of 5, I get 1. If it's log base b, I'm going to pick whatever the b value is, and I'm going to plug it in, and I'm going to get the answer of 1. So over here somewhere, I'm going to plot what b comma 1. I don't know what the base is, but it's going to go over there. Okay, the third point that always comes in nice, since my base was 5, I did 1/5. That's going to help me figure out where the graph's going down. So I'm going to do 1 over b, which is going to give me -1. I don't know where 1 over b is, but I know it's very small, and I'm going to go down 1, which is somewhere down here. And I don't know exactly where it is, but this is just to give me a shape of the graph. So 1 over b comma -1. And since x equals 0 is an asymptote, my graph will not touch that point, that part of the graph. So it's going to go close like this, and it's going to go up here, and it's going to go this way. And those are generally the 3 points I look for on my graph. Okay, let's try to graph a few points. Okay, so this is log base 3 of x. Okay, what am I going to graph first? I'm going to graph 3. If I do the log base 3 of 3, I get 1. So I'm going to go to 3, 1 first. I do not need to label my points. I'm going to label them. So 3, 1. The next good point is 1, 0. And it's because the log base 3 of 1 is 0. So 1, 0 is right here. The third point's going to tell me where this is going up and down. So I'm going to do 1 over the base, -1. My base is 3, so 1/3, -1. 1/3 is just a little bit, and then I go down 1. 1/3, -1. Okay, that's just enough information for me to know it does not cross the y-axis, so it goes down on this way, and then it's going to go a little bit up this way. Let's try the next one. Okay, what's the base on? Oh, let me write what the asymptote is, because apparently I asked for it. Asymptote is x equals 0. Okay, log base 4, so the base is 4. So if I plug in 4, I get 1. 4, 1. The y-intercept is 1, 0. Okay, if I do 1/4, I get -1. So 1/4, -1. And I'm just going to estimate it's about here. Okay, I have 3 points, which is enough information because I know about the asymptote to know that it's going down over here and it's going up this way. My asymptote is still x equals 0 because it does not cross this line. Okay, we're going to do a couple more and then we're going to do some transformations. So this is log base, what's the base? 7. Okay, if I do the log base 7 of 7, I get 1. So 1, 2, 3, 4, 5, 6, 7, 1. Let me do my first dot there. Okay, if I do the log base 7 of 1, I get 0. So that's my x-intercept. If I do the fraction 1/7, I get -1. So if I go a teeny bit over here, I'm going to end up down here. Okay, which does not look like much information, but because I know there is an asymptote, then I know it's going to go down, and it's going to go this way. Okay, one more. This one says log. The base, it doesn't tell me the base. So what's the base? The base is 10 because this is a common log. Okay, so if I do log base 10 of 10, I get 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Way over here. Okay, the x-intercept is 1, 0. And then if I do 1/10, I get -1. 1/10 is like so small, but I'm going to go down 1 here. Which generally it's not enough information, but because we know the shape of the graph, we know it's going to approach the asymptote. And it's going to go this way. Okay, so that's how we graph whatever parent function of log we're working with. So now we're going to try to do some translations. Okay, so f of x is log base 5 of x. G of x is log base 5 of x minus 3. Okay, this is being translated. Since it's x minus 3, which way? Right 3. Okay, I'm going to graph f of x and g of x. Okay, so let's start with f of x. The base is 5. So if I do 5, 1, 2, 3, 4, 5, I get 1. The x-intercept is 1, 0. And if I do 1/5, I get -1. I'm going to draw this in and label it so I don't mix up my points. It goes down on this side, flattens out on this side. Okay, and which one is this? This is f of x. Okay, Now g of x is going to go to the right 3. I can move the points to the right 3, but I also need to move the asymptote to the right 3. So the asymptote is normally right here. I'm going to move the asymptote to the right 3. So now it's right here. We didn't draw it the first time because it's off the graph. Okay, now you can either recenter at our new asymptote and do the parent function, or you can move each point to the right 3. I will do it first with the points and then with the asymptote. So since this is a point, I move it right 3. I take my x-intercept, I move it right 3. And I take that little fraction guy and I move him right 3. 1, 2, 3. And he's very close to the asymptote. Okay, and then I'm going to draw my graph in. It should not cross the new asymptote. Okay, and that's my graph of g. Okay, I said you could do it recentering on the asymptote too. So if I had just moved my asymptote to the right 3, I could treat this like my new y-axis and then graph the parent function from here. So I would have gone from the asymptote, I would have said 1, 2, 3, 4, 5, 1. The x-intercept is 1, 0 from the new asymptote, and then 1/5 down 1. And I could have gotten my graph that way. Okay, my asymptote is normally x equals 0. Since it moved to the right 3, the asymptote is now at x equals 3 because it got moved to the right. Okay, let's do another translation. Okay, so this is f of x is the log base 3 of x. G of x is the log base 3 of x plus 4. So because it's x plus 4, it's moving left 4. Okay, I'm going to graph both f of x and g of x. Okay, f of x has a base of 3, so 3, 1. 1, 0. 1/3, negative 1. Okay, now I want to move this left 4. I'm going to move my asymptote left 4. It's at normally right here. 1, 2, 3, 4. And the asymptote is important. Okay, now you can take this point, move it 4, 4, 4, and get your points, or you can recenter on the new asymptote, which I'm going to try for people who like that better. So this is like my new axis. Normally I go 3, 1. 1, 2, 3, 1. Normally I go 1, 0. So from here I'm going to go 1, 0. And then normally I go 1/3, negative 1. So I'm going to go 1/3, negative 1. And I'm going to end up down here. Okay, those are the same 3 points as if I had moved each individual one over. So it's up to you how you get it. Don't cross your asymptote. Okay, but I am going to label. This one was F. And then my translated one was G. Okay, my new asymptote got moved left 4. So instead of being at 0, negative 1, negative 2, negative 3, negative 4, it is x equals negative 4. Okay, let's try 2 more. Okay, f of x equals log base 4 of x. The translation is it's log base 4 of x, and then it's moved, it's plus 2. So this is going to go up 2. Okay, let's graph f of x first. The base is 4. So 4, 1. 1, 0. 1/4, negative 1. I'm not going to cross the asymptote. Okay, that's nice for my f. Okay, now g of x is moved up 2. Okay, if this is my asymptote, if I move it up 2, it's still the same line, it doesn't do anything. Okay, so I'm going to take each of these points and move them up 2. So this one, let's move it up 2. Next one, I move it up 2, and then that one, I move it up 2. Okay, I'm going to draw my new graph. I'm still not going to cross the asymptote. Okay, and this is G. And if you look at it, it looks like the same graph, and it's moved up 2. Okay, since I didn't move sideways, the asymptote did not move, so my asymptote is still at x equals 0, which I didn't bother drawing because the axis is right there. Okay, one more. D, f of x equals log base 7 of x. G of x is log base 7 of x, and then we're subtracting 5 from the parent function. So this is going to go down 5. Okay, I'm going to graph f first. Base 7, so 1, 2, 3, 4, 5, 6, 7. Hold on, 1, 2, 3, 4, 5, 6, 7, 1. Okay, x-intercept is 1, 0. 1/7 should be negative 1. Okay, I'm going to draw in. It goes down over here. Goes towards this point, that's f. Okay, now I'm going to move it down 5. The asymptote moving down 5 doesn't make a difference. It's already all down there. So I'm going to move each point down 5. So 1, 2, 3, 4, 5. I'm going to move this guy down 5. 1, 2, 3, 4, 5. And then I'm going to move that last point down 5. 1, 2, 3, 4, 5. Okay, and then I'm going to sketch G in. It's still going down towards the asymptote, does not cross. It goes this way. Okay, so that's my graph of G. It does look like it moved down 5. Okay. And the asymptote did not move, so the asymptote is still at x equals 0. And sorry about all the bells.